So these are the kind of questions which you will really push your understanding of maximization, minimization, and maybe because you're using the quadratic equation, so typically you have to know your quadratic equation well also. So I don't think that's an issue. First of all, as usual, try to understand the question. You're told that use differentiation, find the largest area of rectangle, which the sides parallel to the coordinate axis lying above the x-axis and below the curve of this equation. Okay, we know that this equation is set face like that. Okay, like that. So this is a quadratic equation here. The question now is, how can we draw a rectangle so that it's like the largest area, right? So there are a few ways of drawing, right? One is like that also, like that. Here, and like that. Okay. Anyway, it will be like parallel to the x-axis lah. So the question now is, how do you draw so that the area is maximum? So this area doesn't seem very much, like it's not a lot of area. But this area here seems like it's possible, and this area here, okay, seems not as much as this as well. So the question now is, what is the maximum area for the rectangle you draw? Okay, that's the question there. Okay. So what I'm going to do is actually, the first thing is try and find out what is the maximum point. Okay, as far as we know that this point here, just now we use a calculator to okay, if you zoom standard is like that, you can't really see, but you can see that if you zoom fit, it's roughly here. Okay, so in other words, this one, when x is 0, we can quickly tell that this is 44, but I don't think this 44 is useful, so I'm gonna just erase it. What is useful is actually the maximum point here. Okay, because whatever I draw, it will always be symmetrical about the maximum point. Remember, in your in quadratic equation, is always symmetrical about the max point, okay, the turning point. This is x. So one thing I always tell you all is that when you see quadratic equation, you must always develop this uneasiness in you, right? That you must always complete the square. Okay, I like to complete the square. I just don't like to see a quadratic equation without being completed the square, because that is like one of my pet peeves. Like when you want to solve questions like that, right, it's good you just find. So anyway, even if you don't find, you can just find the maximum point here. Many ways lah. There are many ways you can do it. But I just like to complete the square. Okay. So I'll just check. This is 2 and 48, which is true. The max point here is actually 2 and 40. Now, that is it. So when I draw a rectangle, because the side of the rectangle have to be parallel to the y and x-axis, so this is definitely a rectangle which is like that. Okay, is like that. That is the idea here, right? It will be like that. Okay. Now, this is x equals to 2. Right? Let's say this point here is a lah. It doesn't matter, because now you want to you can put a here or put here. It doesn't really matter one. It really doesn't matter, because a is a variable. You can introduce a variable here. So now you're playing with variable. I'm gonna let a be here lah. So I just let a be this side here. This is my a. Okay. So this will be a0. So just take note. Let bottom right let the bottom right vertex be a comma 0. Okay, this is important. So first of all, try and understand this, where a has to be bigger than 2. I just need to make sure it's big. If you use a on the left, then you let a be less than 2. But because now I'm very wary, especially when it comes to quadratic equation, sometimes if we solve a, right, they have 2 equations that I don't really know what's going on. So now I have this variable here, which is a comma 0, and with this a, I think life will be very good. All right, like this a would be my answer to everything. Okay, we just let a be 0 here first. Then I'm going to then find out what is the area of this rectangle based on A law. Okay, because what I want is the area here. So this is, if this is A, then this length here is A minus 2 lah. Am I right? Because if this is 2, so this is just A minus 2, right? So this here is A minus 2 as well, because it's symmetrical ma. Right? It's just symmetrical. It's symmetrical. So you can just know that it's A minus 2. Then the height here would be, the height here would just be FA, right? FA, the height here is FA, because when you put A inside here, this will register the height, which is FA. FA substitute this in, so this will just be 44 plus 4A minus A squared. So the height of rectangle will be equals to FA, which is be 44 plus 4A minus A squared. And the width of breadth, I'm not sure. Of rectangle, is it the width? Is 2, actually, always the breadth times width. I don't even know which is which. The idea is there. Okay. So now, what I want to do is, I want to find, now remember A is the variable, so I want to find the area of rectangle. Okay. This will just be A equals to minus A. This is 44 plus 4A minus A squared. There you go. dA. I shouldn't have used A, but now, okay, hindsight is like that. There you go. This is how you can solve. You can either expand it, or you could just what do you call it? You could just you could just use product rule. Okay, I mean product rule. Yeah. Am I going to expand it? I'm not too sure. Maybe I just dA. Now I want to maximize it or minimize it. I can just dA here. So it's A is A minus 2. Then this is 4 minus 2A plus 44 plus 4A minus A squared. And this will be 1. Okay, great. So this would just be 2 minus 2A squared. Minus 2A minus 2A squared, 4A minus 4A 0, 8. Yeah, A minus 2A plus I think I've done most of the heavy lifting with. So here should be fine. Here will be 4A minus. Okay. 4A minus 2A squared minus 8 plus 4. Okay, great. So this case here will be 2 4A 12A minus 3A squared 12A, and then you have got 44 minus 8, which is 36. Okay. Okay, great. So now do you need to show its maximum? Largest so I can just d square ADX square is minus 6A plus 12. Okay. So this would be less than 0, since A is bigger than 2. Okay, A is bigger than 2, right? So minus 6A will be, if you multiply 12 here, it will be less than 12. Okay, then minus 6A plus 12 is less than 0. So this is 0, so hence A is maximum. You don't need to show, I think it's good to show A is maximum. I'm not sure whether the question requires you of that, but because they say find the largest, so it's maximum. Then once done, so dA 0, that we will get 2 minus 3a squared plus 12a 36. We wouldn't want, we don't want the exact value here, so I can just key in calculator. I'm a bit lazy to find the exact value, but if they want, you know what to do. You just use the quadratic formula there. Oh goodness, so x equals to a equals to minus 2 and 6. So reject as a is bigger than 2. So a is equal to 6. So a, what do we want? Area. So area would be 6, right? Substitute 6 in. Maximum area. Just area. Substitute 6 inside. 2. Then 44. There you go. Key in calculator lah. 44. Yep. Oh. Wait, 256. Square units. Okay, so it's 256 square units. Yeah. So let me just recap. Essentially, you need a variable, and you just express a variable in terms of a, and then just slowly do it. Okay. Why is a height fa? Okay, that's a good one, because if height equals fa, because if I want to find, if this is a here, okay, if this is a, you want to find here with fa, right? You just sub fa inside, that's a height, right? So yeah, that's how you do it. Question, please ask.